Hello everyone, welcome to this brand new lesson. In this lesson, we are going to learn about star rating prediction of Amazon products reviews. A review text data will be given to us, and based on that text data, we have to predict how many stars a user want to give. Alright, perfect. So you have to first visit my Github repository and then visit this repositories column. You need to open this repository, Amazon Musical Reviews Rating Dataset. It has a reviews dataset, and this is available in this file. It is a CSV file, and it has a column which is having a text data, and another column which is having a final star rating. Alright, by default you cannot see it, so that you need to click on view raw, and with this view raw you will be able to see this file in raw format. So it might take a little time to open this. Alright, so it is having many columns here, like a reviewer ID. Let me zoom in so that you can see it clearly. Alright, it has a reviewer ID and reviewer's name and helpful, review text, overall summary, etc. Alright, so what we are going to do, we are going to read this CSV file in a pandas data frame. Alright, let's go ahead, connect this notebook in meantime and import here pandas as a PD, and we are also gonna import here NumPy as NP. Let's go ahead and run it. Alright, in meantime it will import pandas and NumPy. Thereafter you need to read that file, so read CSV. Thereafter you can simply give its name, the file address. Therefore we are going to read it in a data frame which is df. Let's go ahead and see first few lines of this data frame that we can see with the head. Alright, in meantime let's go ahead and bring it in full screen mode so that we can see it. Alright, so it is having here reviewer ID, a scene, alright, and reviewer name, helpful, whether how many people has found it helpful and not helpful. There is review text and overall star rating and summary, etc. Alright, so we are interested in these two column only. In these two column only. The first column is review text data and there is overall rating. So what we are going to do here, we are going to assign here load only these two columns. That we can do simply by putting here use calls. Alright, use calls, that's mean use column is equal to, we are gonna see here this review text, and we are going to also take it with this overall. Alright, perfect. Let's go ahead and read it. It says that it do not have any call. I think it's use call perhaps. Alright, superb. Now we are having here our review text and overall rating to that particular review. Alright, and if you want to see some sample, some random numbers, you can simply type there dataframe.sample, and it is giving here overall rating. Now let's go ahead and see how many ratings, how many different types of rating we have currently. So we can simply see it with the data frame, and here overall dot value underscore counts. So it says that we are having here a 6,000 5-star rating, around 7,000, and 2,000 is 4-star rating, and there is 700 and 250 is 2-star rating, and 217 is 1-star rating. Alright, perfect. So we have got our data set. Now let's go ahead and do some pre-processing on this data set. So for the pre-processing, as usual, you have to visit my GitHub repository, GitHub LangChain BERT, and there we have KGP Talkie pre-process Python package for text data pre-processing. All right, so this is a pre-process KGP Talkie. Then you need to, all right, click on copy this one, install. All right, pip install this one. Thereafter we are gonna install it here. All right, so this is KGP Talkie pre-process package, and if you again come back to this repository, this repository needs these dependencies. So by default, these dependencies are already installed in Google Colab, so we don't need to install it separately. And other than that, this is the get clean method which we will be using. So these are some methods which are already implemented in this pre-process package. So we can simply use this whole method and we don't need to do the extra pre-processing. All right, now let's go ahead and import here pre-process KGP Talkie as PS. Thereafter import, here I'm gonna do here import RE, that's means regular expression. Let's go ahead and paste this get clean. All right, so what this get clean is doing here, let me explain you. This one is converting into lowercase and replacing any backward slash with nothing, underscore with a space. Thereafter there is a contraction to expansion is happening here. You need to read more about this. Go ahead at my GitHub repository. Then this is removing emails, URLs, HTML tags, retweets if there. So this is review text data, so we don't need that. And there is accented characters, remove special characters, and these are the multiple repeated characters. All right, so all these pre-processings are happening here. Let's go ahead and pre-process our data frame data, which we can simply do like this one. df review text is equal to df review text, sorry, dot apply, and there we are going to use here a lambda function. All right, in this lambda function we are going to call this get clean. All right, perfect, copy it and paste it here, and in that we are passing here a data row by row for this review text. It might take a time, it might take a while to complete this pre-process, so it just took a few seconds to complete it. Let's go ahead and once again see here first few lines of our data frame. Now it is a pre-process data frame. All right, perfect. So we have successfully pre-processed our data. Let's go ahead and implement our algorithm. So we are going to use here TF-IDF and linear SVC algorithm. All right, so it's linear SVM algorithm. And for this linear SVM algorithms and TF-IDF, we need to import some packages from Scikit-Learn. Let's go ahead and import those. So we are going to import it from Scikit-Learn dot feature selection. It's the feature extraction dot text. Then we are going to import here TF-IDF vectorizer. All right, thereafter from Scikit-Learn dot model selection import train test split. All right, so we'll be needing this train test split to divide our data set. Thereafter we have here from Scikit-Learn dot svm import linear SVC. So linear SVC is a linear model of support vector machine, which is SVM. Thereafter from Scikit-Learn dot metrics import classification report. So this classification report we will be needing to evaluate our machine learning model. Now let's go ahead and create TF-IDF vectorizer. So TF-IDF is equal to TF IDF vectorizer, and in this TF IDF vectorizer we are gonna select here, I don't know how this is going to. All right, so this TF IDF, in this TF IDF vectorizer, I'm gonna pass here few parameters. By default, you don't need to pass any parameters, but still I'm gonna pass here few parameters like max features. So I'm gonna select here max features to only 20,000 features. Thereafter, I'm gonna also select here n-gram range. So this n-gram range, I'm gonna select here 1 and 3. That's mean it is going to select here unigram, bigram and trigram. And the analyzer for the tokenization, I'm gonna use here character analyzer. That's mean tokenization will be happening here a character level, at the character level. All right, so with this, I have got here the TF-IDF vectorizer object. Let's go ahead and get our X vector. We can simply get our X vector. X is equal to TF-IDF dot fit underscore transform. Thereafter, you need to pass here this data frame, and in this data frame, we have our review text. All right. Thereafter, Y is equal to data frame, and there we have overall rating. So we have got our X vector and Y vector. You can also, just a second. You can also check the shape of these vectors with X dot shape and then Y dot shape. So it says that X is having 10,261 rows, and there are total 13,547 features only. All right. So as you know here, we had selected only n-gram to 3. That's mean max feature is 20,000, but still the total number of features are only limited to 13,000. So it is not increasing. Otherwise, it might have been limited to only 20,000 features. All right, we have now our X vector and Y vector. Let's go ahead and do train test split. So I can simply do here X underscore train. Thereafter, we have X test, Y train. Then we have here Y test is equal to train test split. All right, so in this train test split, I'm going to pass here X, Y data. Thereafter, I'm having here the test size. All right, so this test size, I'm going to pass here only the 0.2. That's mean only the 20% of the data will be used for a testing. And the random state I'm going to select here is equal to 0. So we have got here X train, X test, Y train and Y test. Thereafter, I'm going to do here X underscore train dot shape. So with this, you can check how many samples we are going to pass in the training set. All right, so we have our data set. Let's go ahead and create our linear SVC model. So it's a simple CLF is equal to linear SVC. Thereafter, CLF dot fit, and then we are going to pass here X train, and then here we have Y train. All right, let's go ahead and run it. So once you run it, you have CLF is equal to linear SVC and your model is trained here. Let's go ahead and do ypred. Ypred is equal to CLF dot predict. And in this, I'm going to use here X underscore test. All right, so with this, I'm getting here Y predicted value. Let's go ahead and see the accuracy, how much accuracy we are getting here. So we have classification report. So with this classification report, we will be getting here precision, recall and F1 score. All right, then here we have Y test, which is a true value. And then we have here Y pred, which is predicted value. It says that we get here almost 68% of the accuracy. All right, and for the 5-star, we are getting here a quite good accuracy. but for a 3-star, 1-star and the 2-star, the accuracy is not coming good. All right, so the moreover these things are not coming good. So what we can do, we can optimize this algorithm by putting here c is equal to 2.0, let's say. Otherwise, let's go ahead and make it 10. All right, so we are gonna regularize it so that we can do some regularization on the prediction. All right, so it might take a while to complete its training. Let's go ahead and wait for it. All right, so in between I had just stopped this video and wanted to test what are some other hyperparameters which I can tune here. So as you can see with this particular setting, we are not getting quite good accuracy, precision recall and F1 score. Because this data set is unbalanced data set, so accuracy is not a good measure to accurately assess the model performance. So the best way to assess the model performance is here precision recall and the F1 score. So for 5-star rating, it's coming quite good, but for 1-star and the 2-star, this is not coming quite good accuracy. All right, so what we can do, either we can do here this data set balancing. Otherwise, this linear SVC have one parameter which is known as you can see here, it should be somewhere. Let me see. Linear SVC have a class weight parameter. All right, so this class weight parameter, if we set this class weight parameter to balanced parameter, then it will try to balance the overall accuracy. So what it will do, it will try to improve the precision recall and F1 score for 2-star rating as well. So this class weight is especially made for the dataset which have unbalanced dataset. So there I'm gonna provide class weight is equal to, if you notice, if you read here, let me show you. Here you will have this class weight. All right. So I'm gonna use here the class weight is equal to balanced. All right. So it says that balanced mode uses the values of y to automatically adjust weights inversely proportional to the class frequencies in the input data. All right, that's mean it will try to balance for the less number of the data. All right, so with this, let's go ahead and retrain this model and see if we can see here any improvement over the performance. Let's go ahead and run it. All right, you might be seeing here the different cell numbers after I, they stopped the video. It is happening because I was testing it, how we can improve the accuracy. All right, so I did some testing and found out that if we do here a class weight is equal to balanced, we can get here a better precision recall and F1 score. So in this case, we are getting here a 62% of the overall accuracy, and for a 2-star, although this precision recall and F1 score is quite low, it's almost the pretty much low, but still whatever we had earlier, it's better than that one. Apart from that, you can also change here as well. So we are going to make this n-gram range to 5, and then analyzer is corrector. That's okay. Let's go ahead and run it once again. All right, so we need to rerun all those things once again. And one more thing, what we can do, we can increase this C. So C is inverse of the parameter regulation. So if you increase it, this C, all right, so it regulates the hyperparameters. So I'm going to stop it and then I'll make it 20. Just stop it. Let's go ahead and rerun it once again so that we can set here C is equal to 20. It might take a time because we have provided here class weight is equal to balanced. So in this case, it will do a lot of pre-processing internally, this algorithm. All right. All right, so the model training is done for C is equal to 20 and class is balanced. Let's go ahead and run this one and this cell as well. So here once again, we are getting here a better score, the other than the previous one. Now let's go ahead and see the test it with the real data. And the real data, I'm gonna say here x is equal to let's say I say here this product is all right, really bad, I do not like it. All right, thereafter we are gonna get here get clean, although it is already clean, so we don't need to do that actually, but still whatever pre-processing you have applied previously, you have to apply all those pre-processing. So you need to provide this x in a list format. Thereafter I'm doing here clf dot predict, and there I'm passing here a vector. Let's go ahead and do the prediction for this one. So it says that this is 1-star rating. All right, and really, I mean, if I say this one, I might give here 1-star rating. But in another way, let's say if I say that this product is really good, all right, thanks a lot for speedy delivery. Let's go ahead and run it and then see how much star we are getting here. So with this, we are getting here a 5-star rating. You know what is happening here? So these errors are actually coming because a lot of 1-star rating is being, you know, the 3 in the 2-star, and these 2-star are being misclassified with the 1-star. That is why happening. Otherwise, this algorithm is doing quite good. All right, so overall accuracy might seem slow here, but if you really notice with these experiment, you will find that okay, this is performing quite good. And apart from that, if you use some hyperparameter tuning and some advanced algorithm like BERT and XLNet, you might be able to improve this accuracy. You might be able to improve this accuracy better than this whatever we are getting here currently. Alright, perfect. So this is all about in this lesson. Thanks a lot for watching it, and please do like and subscribe this channel. Bye bye. Have a nice day.